They're different beasts. Almost all of the classes that you are going to use in R are going to be this, are going to be S3. And it's really more of a confusion about the differences, but you need to be aware of that. Okay, enough of that. Okay, finally, we're getting into functions. This really goes to the heart of programming in R. The heart of programming in R consists of writing functions and mastering the control structures of functions. And really, when you get down to it, it's pretty simple. Okay, let's look at an example. Let's look at the structure of a function to begin with. The structure of a function, the syntax of a function. Okay, whenever you're creating your own function, you're writing a program. Functions do things. Functions perform tasks. Functions perform behavior. R looks for the function keyword. Whenever R sees this keyword, function, reserved, it knows that you're creating a function. You're defining a function for the first time. Okay, so we're creating a function and we're naming it this, odd count. So what are the parts to this function? Okay, this is the name. This is the keyword that tells R that it's a function. This is the formal parameter list, or if you prefer, formal argument list. This denotes the beginning of the body. And note when I highlight this in RStudio, it helps us out by highlighting the mate, because we have nested blocks. These are block statements. That's what this is. These are common to other programming languages like Java that help you put order, precedence to your sets of statements. These are block statements. Now, as far as the R interpreter, this whole thing is one line. You can't read in half of this and then read in the other half. How do you read it in? Well, one way to read it in, if we look up here in our workspace, you don't see any functions. We see data. We have data sets, and note you can click on them. There's one of them. There's the other one. You have variables that are under the header values. Here all are variables, and these are mostly vectors, lists. These are individual structures. Watch what happens when I do this. If I highlight this function that I'm creating and hit run, suddenly up here in the session in the workspace, now we have a new banner, functions, and odd count is there. We can take a look at odd count, double click on it. Here's odd count. Okay, let's clear out the workspace, get rid of everything. I did it the simple way. You can also do it by using the rm command, but let's just do it this way. So I hit clear all and I say yes. Okay, everything's gone. You can read in a function line by line, but watch what happens. When I start hitting run, I put my cursor on the first line, hit run. It moves the cursor down to the next line, but in the console, note that you see a little plus. That means I know R is telling you we're still on the same line. You only entered in this much, but I didn't see the end of the statement. So I'm going to put a plus here that means just keep typing, that it's all the same line. So if I hit run again, it reads in that part of it and just gives me another plus. So if I keep doing that, it'll parse all the way down through the entire function till it gets to the matching ending block designator, and then we'll get the prompt back. And now at this point, there's odd count. We've got odd count. And you can call it. Okay, what does odd count do? Well, let's take a look. Odd count, if we take a look at the function itself, odd count will accept one parameter as input, one argument, a variable that it will assign to x when the function is called. And then we go in here, and so the first thing that happens in odd count is it creates this local variable k, and it initializes it, assigns the value of 0. Okay, k is going to store our results. K is just going to be a counter. Okay, then it goes into this for loop, and the for loop, here's the heart of it. What we're trying to do is whatever vector is input, we want to count the number of odd integers. Not the even integers, just the odd ones. Okay, well, how can we do that? Well, we could take the modulo. We could divide each element by 2. And if the remainder is 0, it's even. If the remainder is 1, it's an odd number. And we want to add it to our counter. Okay, that's exactly what this for statement and this if statement does. The for is a loop. It loops through this. N walks through the vector. N is 1, N is 3, N is 5. And it takes each value of the vector and divides by 2 and looks and sees if there's a remainder. And if there is a remainder, it adds 1 to k and puts that in k. And then when we're done looping through the vector, whatever k is gets returned by the function. Now, so let's try it. Okay, we'll say odd count, and we'll pass in this as the argument. So we do that, and it says 3, returns a 3. Yes, there were 3 odd numbers. Okay, let's do another one. We'll pass in this vector, which has 5 elements, and 4 of them are odd. So we run that, and it returns 4. So it seems to be working okay. Seems to be working properly. Now, here's note. Here's our function, right? Here's the function all together. Note, and this is a good habit to get into when you're defining functions yourself, especially if somebody else is going to look at them. You can insert comments not only after each statement like this, but you can insert comments in between the lines, as many as you want, like this. Okay, so here's the same function, but it's explained better. It's explicated, if I can say that, in more detail, telling us everything we're doing. Okay, it's good to document. Now, a couple of things about functions. Okay, so that's how you write a function. Now you know how to write a function. You can do the assignment, right? You need to write the body in the assignment, the body that does those steps. And you don't need a for loop. I don't think. You don't. No, you don't need, this is a control structure. You don't need anything fancy. You don't need an if statement. You can just put in commands to execute those 4 subtasks that are itemized on the assignment. Okay, note a couple of things here. First of all, functions in R only return one thing. That's all. And what that is, the thing they return is always simply the last thing that gets executed in the body. Unless it encounters this. Whenever it encounters a return statement, this is a function. This is a reserved function. The return statement does not have to be at the bottom like it is here. You can put a return statement anywhere in the body that you want. And whenever it hits that return, it'll do it. It'll send out, return means send whatever the argument is back out and kill the function. Stop it. Terminate the function. So return is handy. Return is handy when you have loops or you have, it's complex and you might want to exit at different points depending on the values of variables. You can have multiple return statements in a function, but as soon as it hits the first one, it's done. Okay? So return gives you a little more control because you can send it on its way. You can leave the function and return the value. But you don't need it. This function will work just fine if I just do this. If I just take this whole line and just do this. Let's do this. So I'll read in the function like this without return, and then we'll call it with those same, call it up here. It works just fine. If I say 4, works just fine. You don't need to use return. Okay, we did here. And it's useful in some places, but it returns this because it's the last thing. It'll go through this for loop until it runs out of elements in the vector, and then it'll fall down to this line. That's why K gets returned successfully here, okay? Now, so that's one thing about functions. Return, it's just like Java. It's the same thing in Java. Okay, another thing which is common to other languages, the variables that we use inside the function only live inside the function. They die. They're gone when the function stops executing. That is, and there really are 3 different types. They're usually called local, but there are 3 types of local variables. A local variable means it's the name, it gets named in the function. X is local, K is local, N is local. But these local, the ones that are in the list of formal arguments are called formal arguments. They're local, but they're formal arguments. They have a special meaning. They always have a value. Almost always, even if it's the default value. And these local variables that are assigned a value in the function itself, they're usually on the left-hand side of an assignment statement. These are the ones that are usually called local. They are bound. They get bound with a value. And so their value is determined. They don't just, they always have a value, as do the formal. But you also have what's known as free variables, and we don't have any in this. Free variables, which are local variables inside a function, that may or may not be assigned a value. Depends. And free variables are where it gets interesting.